Today's video is going to be a short look at changing improper fractions to a mixed number. So when we are looking at these fractions, for example 32 over 5, we need to remember that this fraction represents a value larger than 1. When the numerator is larger than the denominator, the value is larger than 1. So we should have a mixed number because we will have a whole number representing the values larger than 1 and possibly still a fraction left over, but not always. So if we take a look at our first example, if you understand what the fraction bar represents, then you will easily be able to solve these problems. Let's think about our 4 operations. The fraction as a whole looks like one of our operations. We have our fraction bar, and we have 2 numbers. Do you see what operation we're representing? Hopefully you see it's division. The fraction bar is merely a division problem. This is 32 divided by 5. And now all I need to use are my division strategies to solve. I know that 5 times 6 is 30. 2 is my remainder. So my answer is 6 and 2/5. Remember that your denominator should always remain the same. Now to check, I could do this one of 2 ways. I could draw out my representation of 6 and 2/5 to see it as an improper fraction. I know there's 5/5 in each, so I have 5, 10, 15, 20, 25, 30, 31, 32. That gives me 32/5, which matches the original improper fraction. Or I could use my strategy. 6 times 5 is 30, plus 2 is 32/5. So I can just go back and forth between mixed numbers and improper fractions to check my answers. We're going to do a couple practice problems together. We have 43 over 6. Using your scrap paper, pause the video and try to use division to find the mixed number. I am going to start solving now. So I remember that my fraction bar represents division. So I have 43 divided by 6. I know 6 times 5 is 30. And 6 times 2 is 12. So for my answer, I have 7 and 1 out of 6. And again, I can check. 7 times 6 is 42, plus 1 is 43. Our last example here is 81 over 9. Go ahead and pause it and solve. For this, I remember that I'm using division. 81 divided by 9. I know that 9 times 6 is 54. And 9 times 3 is 27. So here, in this interesting result, we have 0 as a remainder. So all that means is this improper fraction just represents an exact whole number of 9, and there is no fraction to add to it, and that's because 81 is divisible by 9.